Bismillahirrahmanirrahim. Salamun alaikum. In the online session we had on Saturday, we talked about the key value databases, and we said that the key value database is the simplest NoSQL database. We talked about key values, and we said that a key value is a more complex structure than the array, and we said that the key value is something similar to the associative array. In the associative array, the index could be anything, and the type of the values, it's not limited to be the same. And so the key value is something similar to the associative array, and we said that key is a reference to a value, and it could be different. We could have different types of keys, and the value is the data that we are storing. So each data, it has a key that refers to it, and the value is the data that we are storing in the database. And in the key value database, we have a concept. We said that we have a concept namespace. Namespace is we divide the data into some namespaces, and in each namespace we don't have duplicate keys. Okay, we talked about this in the online session. And then we said, how could we construct keys in the key value database? How could we construct keys? We could construct a key using this method: the entity name, the entity identifier, and the entity attribute. Okay, we talked about it. And we said, how could we relate the keys and values in the key value database? How could we relate them? We said that we relate the keys and values using the hash function. We get the hash function of the key, and then we store the value in the address that the hash function generates. Okay, we store the values in that place on the hard disk. And there was a problem in the hash function that we talked about it: collision. And then we said, how could we convert a relational database to key value database? Okay, we talked about it. In this example, you see that we have a customer table, and the customer, it has some attributes. These are the keys for the different attributes of a specific customer. Okay, this is the customer ID. This is a specific customer, and these are the keys that we have for that customer. And then we said that the key value database, it has the main features are simplicity. It is very simple. It has no schema, and no limitations on the data types. The data types could be anything. And sorry. This was some examples about this. And then for the speed, we said that the key value database uses the RAM of the computer to accelerate the speed. When we do a write operation, it is done in the RAM, and then the server sends an acknowledge for the client. It says that the operation is done, and then the operation is done later on the hard disk. Okay, and the topic which we were talking about was scalability. Scalability is adding some servers to the system so we could answer to the user requests. In the key value database, we have the scalability concept, as we said, and first we talked about the cluster. The cluster is a group of servers that they are connected, and the ring is a logical structure in the cluster. The partition is a group of servers in the cluster that do a specific job or task, and the partition, it could be different workloads. The partition key is a key that we could use to access to a partition. And okay, replication. We came to here, replication. Okay, we talked about replication in the last slides that we talked about the relational database. We said that replication is having some copies of the database. That's replication. Okay, we have some copies of our data, and having these copies helps us to have high availability. Having these copies helps us to have high availability. High availability means that if a server fails, still our system is available. This is the meaning of high availability. When a server fails, our system could still work for us. And okay, in the for the replication, we have we could have two strategies for the replication. The first strategy is the master-slave replication. Okay, the first strategy for replication in the key value database is the master-slave replication. Okay, in the master-slave replication, this strategy for replication could help us for scaling the read operation. Okay, in this strategy, we add servers that could help us to respond to the queries or the read operation. The query is the read operation. Okay, and as we said before, many applications, most of the applications, the number of read operations is much more than the write operation. The read operation is much more than the write operation. Okay, people, when they want to buy something in the online stores, they do a lot of search. All of these search, they are read operations, and then they buy something. So it is reasonable to have more servers for the read operations. Okay, in the master slave replication, the master is a server in the cluster. Okay, we have a cluster. A cluster, as we said, is a group of servers that are connected. The master accepts the write operations and also the read operations. And the master is responsible for maintaining the master record of all the writes operation and the replicating or copying. Okay, all of the data about the operations that is done in the cluster, it is stored in the master server. And the other servers are doing only the read request, the read operations. So we have a master server that could do read and write, and also stores information about the replication and the copies of data and the updates, okay, and different operations in the database. But the problem that we have in the master slave replication is that the master could fail. Okay, the master could fail. Okay, it may be with different reasons. Okay, the electricity or software issues, okay, a virus, anything. The server could fail. Okay, so what do we do when this happens? In the master slave replication, when the master server fails, what happens? Okay, the other servers, that are working, they recognize that the master has failed. Okay, because they send a message and the master doesn't send a response, so they know that the master has failed. Okay, when this happens, the slave servers, they send some message between them and they select a new master in the cluster. Okay, so when the master server fails, the slave servers, they send some messages and they select a new master server. And from that point, the operations will continue with a new master server. Okay, so this problem could be resolved like this. Okay, so if we have a master slave replication, we said that the master is responsible for the read and write operation. Okay, and the slaves are responsible only for read operation. But if the master server fails, okay, one of the slave servers, they are selected based on some messages that are sent between them, and then the cluster could continue its operations. Okay, so this is one type of replication that we have that could be used in the key value database. So we have some copies of the data and they could help to have scalability in the read operations. Okay, thank you very much. Bismillah ar-Rahman ar-Rahim. In this video, I want to start the subject of NoSQL database. Okay, the NoSQL database, if we want to have a very simple definition of it, is that it is a database which the data model is not based on tables, and or it is non-relational. It is non-relational. Okay, it is something different from the SQL database. Okay, in the SQL database, we have a specific structure. NoSQL database is something different from that. Okay, if we want to talk about the history of databases and the different platforms that we have, this is a very good slide. The first platform that it was a very time ago, it was the mainframe computers and the mini computers. In these platforms of computers, the databases which were used were hierarchical database, network database. These were the two different databases that was used in these platforms. This was the first platform. Maybe about 50 years ago or more. Okay. After that, in the second platform of the databases, which were important, was the client server and the web. This platform started in the 1990s. 1990s. Okay, and when the websites were first built, this platform started. The database which was used in this platform was the relational database. The database for this client server and website platform was the relational database. Okay, and the third platform is the situation that we have right now. It is the cloud computing, social networks, big data, mobile data, IoT. In these platforms, the databases that are working for us, still the relational database is working in some of these. The NoSQL, the NeoSQL, and the big data platforms. Okay, so we are managing the data in these platforms using these four technologies. That here we want to talk about the NoSQL database. Okay, we want to talk about the NoSQL database. So as you see, the relational database is still being used in these platforms, but it is used in some specific applications. Okay, when do we use the NoSQL database? This is very important. Okay, when the data volume is very big, this is one reason we may use a NoSQL database. The second reason, when the transactions are very much, transactions mean the operations, when the operations on the data are very much and very high, we use the NoSQL database. And the third point is that when the data is not in the format of tables. Okay, sometimes we have data that is not in the format of tables. So in this situation, we may use the NoSQL databases. Okay, these are very important reasons that we go to the NoSQL database. For example, about this third one, for example, if we have a book and we want to store some data about books, okay, in a book we have tree structure. Okay, for example, a book, it has a cover, it has some parts, some chapters, some headings, and some subheadings. Okay, it is a tree structure. The table, the table structure in the relational database, it is not suitable for data which has a tree structure and it is hierarchical. It's not suitable. So this may be a reason we use the NoSQL databases. Okay, if we want to have a brief history of the NoSQL database, it was first started in 2006 when Google released a paper about the Big Table. Big Table was the first NoSQL database that was introduced by Google. Okay, so this was the first, and the second NoSQL database, it was released by Amazon in 2007, and the name of this database was Dynamo. Bigtable and Dynamo are two NoSQL databases which were introduced about 15 years ago. Okay. Now, the NoSQL databases, they have some common features. These are the common features that are true in most of the NoSQL database. The first feature is schema agnostic. Schema agnostic means that the NoSQL database doesn't have a schema. Okay, the NoSQL database doesn't have a schema. What is schema? Schema is the definition of the database. Okay, what data do we have? What are the attributes? What are the type of the attributes? Okay, it is the initial definition of the data. We have this schema in the relational database. Okay, but in the NoSQL database we don't have schemas. Okay, schema is not required in the NoSQL database. Okay, so this is the first common feature in the NoSQL database, that they usually don't have a schema. There isn't a description about the data. Okay, before it is used. It means that we store the data in the NoSQL database and then we do some operations on it. We don't have a definition before we start to work with it. The second feature is non-relational. Okay, what do we mean by non-relational? Okay, relation, we talked about relation in the previous sessions. We said that in the relational database we have some foreign keys. Foreign keys relate different tables to each other. Okay, we don't have these relations in the NoSQL database. Okay, we don't have relations between different data, and all of the data is stored together as an aggregate, a single record. Okay, for example, when a customer wants to buy something, okay, when a customer wants to buy something, he buys a product, and then there is a table in the relational database. There is a table where the product information is stored. Then there is a table with the delivery details. it means that where should the product be delivered. Okay, uh, so we have two tables, and then these two tables are related. One table about the products that are brought, and uh, uh, one table about the delivery details of the products. And these two tables are related. But in the NoSQL database, all of these data are stored together. The data about what a customer has bought, and also the delivery details, all of them are stored together. So we don't need to relate data. This is very important. Okay, these are some examples about this feature in the NoSQL database, that the NoSQL database is non-relational, and this this feature helps to in the NoSQL database to have an easier storage of data and a faster speed in the operations. When in the relational database, the data is in different tables, so first we have to join them together, and join is time consuming in the relational database. But in the NoSQL database, all of the data is stored together, so we don't need to join it, so the operations would be faster. One other feature of the NoSQL database is commodity hardware. Commodity hardware means that the NoSQL database could be deployed and installed on very simple hardware. We don't need very advanced hardware. In the relational database, we need advanced hardware. But in the NoSQL database, we could use any computer and add it to our servers. This is very important. And the last feature that is very important in the NoSQL database, that they are highly distributable. Distributedness is very important in the NoSQL database, and the data is distributed in a cluster, and the cluster is composed of some servers that they are working with each other. Okay, we will talk about the key value, the document, the column, and the graph databases. These are four different NoSQL databases that we will talk about them, and these are some examples of these four types of NoSQL database. For example, in the key value, a REAC is an example key value database, or in the document database, MongoDB is an example. In the column database, Cassandra is an example, and in the graph database, Neo4j is an example of the graph database. These are some examples of these different types of NoSQL database. Okay, thank you very much.